Hello, students. How are you? Fine? Very good. Today we are going to discuss some problems on current electricity. Okay, you have already covered up all the topics of current electricity. Okay, you have understood the basic definition of electric current. You understood the resistance, combination of resistance, method of symmetry to find the equivalent resistance, Wheatstone bridge, meter bridge, potentiometer. No? All topics you have covered till now. If you have any problem in conceptual part, you please go through the videos once more. Okay. Today we are going to give a quick revision, a numerical revision you can say. Okay. And I am going to try give you one interesting numerical here. So that almost all the topics of the current electricity chapter included in the problem. Okay, guys, get ready with your pen and page and start copying whatever written on the board. Good. Okay, let me draw one circuit. You also simultaneously draw with me. Say this is one resistance, this is another resistance, this is another resistance, this is another resistance. Okay, then this is one resistance, this is one resistance, here also another resistance is there. Okay, then say this is 2 ohm, that is also 2 ohm. Okay, that is also 2 ohm, 2 ohm, 3 ohm, that is also 2 ohm, 2 ohm. Here another resistance is there. Okay, say 2 ohm. Just you keep writing with me, along with me. You keep noting all these things. I am going to ask you a big question. Okay, good. This is another resistance. Say this is 8 ohm. Okay, and this is another resistance. Say this is 4 ohm. This is again say this is 8 ohm. This is 2 ohm. This is 2 ohm. That way you can make it very complicated figure, no problem. Just try to understand the skill only. A lot of resistors you can put that way, no problem. You write all these things, and I am going to ask you a lot of questions from this network. Okay, I am going to ask you a lot of questions on this network. Say names the corners. Okay, A, B, C, D, E, F, Z, H. This is a part of a circuit. Okay, and then say current in this branch is given as 1 ampere. Remember, only in the whole network, only in one branch the current is given 1 ampere. Okay, now I have some question. That A, B, C, D, E, F, Z, H. So this point is J, this point is K. Okay, my first question, part 1, this is question number, which a lot of parts are there, part 1. Okay, find current between J and E. Okay, but I need to find out this current from J to E. Find JE. Find current through the branch JE. First question. Second question. Lot of question can be asked, but I am asking. Second question. Find VDE. Okay. Potential difference between D and E. That can be asked. Question number 3. Find current through EF. What is the current through this? That can be asked. 4. find current through B and F. From B to F in this branch, what is the current through this 8 ohm? Okay, lot of question can be asked. 5. Find power dissipated through this 4 ohm. Okay, I think only one 4 ohm is there, na? So you can directly write down. Find P at 4 ohm. Power at 4 ohm. Okay, good. And one more question can be asked. Lot of questions can be asked. Okay, find heat dissipated through this. Okay, so this is R, this resistance is R. Okay, find heat dissipated through the resistor R equal to 2 ohm in the branch AB in 2 seconds. Okay, what is the energy liberated from this resistor in 2 seconds? Okay, we are going to calculate all these things, and you have understood now. Questions can be anything, any questions can be asked. What is the potential difference between C and D, Z? What is the potential difference between B and Z? Anything can be asked. Once you got the picture, all can be calculated. Okay, and even you can also frame some questions. Good. First, you just copy all these questions, because I need some space now. I'll keep on rubbing all these things now. See, solution. It is very easy question. It is not a tough question, but it is a conceptual question. Once you understand, it will become very easier. You can do one thing now. You give a pause on the video and try all these things as much as possible. Okay, for you, try to do, if possible, do all these things. Okay, then you go with my video. Okay, good. But I'll go now, no problem. See, the current through this 2 ohm is given 1 ampere. Na? That is given I from D to Z equal 1 ampere. Okay. Now you see this network DZEK. This network comes under the Wheatstone-Bridge principle, balanced Wheatstone-Bridge principle, because P upon Q equal to R upon S, 2 by 2 equal to 2 by 2. It means J and K will be at the same potential, so no current will be flowing through 3 ohm. Balanced Wheatstone-Bridge principle. And that can be also a question for you. What is the current through 3 ohm? Answer is 0. I have not asked till now, but that may be asked. So what is the current through 3 ohm? It is 0. So as no current passes through this, so that 1 ampere must flow through the 2 ohm itself. So current, therefore current through JE equal 1 ampere itself. It means one question is understood. Okay, what I need to do now, find the potential difference between D and E. What is the potential difference between D and E? Okay, I want to give you a technique to find the potential difference. Okay, first roughly if I say this is 2 ohm, this is 1 ampere, it means voltage drop here will be V equal to IR. Main formula is this. The current is 1 ampere, that is 2 ohm. It means voltage across DJ equal to 2 into 1 equal to 2 volt. Okay, that is JE, voltage across JE, current is 1 ampere, resistance is 2 ohm. So So current into resistance again 2 volt. Are you getting my point? So total potential difference between D and E will be 2 plus 2 4. Okay, directly also you can do, but you can go through some techniques also, na. Using that technique, the technique is a little bit longer, but still it should be learned by you, so as to do some complicated problems. Okay, how I am calculating, as you know, the potential difference V and E, potential difference potential difference between D and E is 2 volt plus 2 volt, means 4 volt, na. So answer is known to you, but still I am going to solve this answer only with some different way. What is the different way? You see, say you are asked to calculate the potential difference between any 2 points, say D and E. So what you need to do, first you should put plus VD. First point you should put plus, okay, plus VD. Then you go through the resistors so that you get E. It means you follow this path, okay, so as to reach E. From D, as you go here, you find some potential difference. Potential difference is minus IR, okay. Why minus? Because current is going this way, so this point will be high potential, this point will be low potential, and the change is seen to be negative. Why? Change is always final potential minus initial. Final is low, initial is high, so difference is negative, na? But change is negative, not difference. Change is negative. Difference always greater minus smaller, and change is always final minus initial. So as the current is flowing that way, that is the low potential, that is the high potential, because we know that current always flows from high potential to low potential. So that is why change will be negative. Negative. What is the change at the resistor? Current into resistance. Current is what? 1 ampere. Resistance is what? 2 ohm. Okay. Now you have reached J. Then going towards this, you see some change here. That will be high potential, that will be low potential, because current is going that way. Okay. Again you will change, you will see change negative. And what will the change? Current into resistance. Okay. Then you finally got the point E. So you have to write VE equal to VE. Okay. That is the way of doing. It means you are indirectly applying Kirchhoff's law only, that loop law. Though it is not forming a loop, it is a branch, but technically I have applied that Kirchhoff's law only. Okay. Yeah, you can put minus VE equal to 0. Same thing. Okay. So from this, what you get? VD minus VE equal to that one 4 volt. This is nothing but VDE, na? That is nothing but VDE. What I have said, na? This is nothing but VDE equal 4 volt. Okay, the answer you have already found. But that method, I think it is a very important method. According to this method, now you can find any potential difference between any 2 points, between A and F also. From A you have to go to F. I'll practice, okay, later if time permits. But now the second answer is VD equal to 4. It means second question is also done. Now I need to find out current through EF. Where is E? Where is E? That is E. That is F. What is the current through it? You see. The potential difference between this point and this point, DE is 4 volt. It means this branch is getting 4 volt and these two resistors are in parallel to this. Okay. So this branch also will get the same voltage, 4 volt. Okay. Because they are parallel, na? These two resistor and these two resistor, they are parallel. So these two resistor also will get 4 volt. So what should be the current here? Current through this is voltage by resistance. Voltage by resistance. So I can write current through DKE equal, what is the total voltage? 4. What is the total resistance? That is also 4. I think 1 ampere. Okay. Means in this branch also 1 ampere flowing. In that branch also 1 ampere flowing, and both the current meeting at this point. So what should be the current outgoing? At this point incoming current is 1 and 1, so outgoing current must be 2 ampere. It means through this 2 ohm resistor 2 ampere current is flowing. It means from E to F 2 ampere current is flowing. Therefore current from E to F is 1 plus 1 equal to 2 ampere. You see, step by step I am solving all the problems using Kirchhoff's law, using Ohm's law, V equal to IR, all the formula used. It means I have already calculated up to the point 3. So if you don't mind, I want to wrap these 3 questions so that I manage some space. Okay, good for your cooperation. Okay, nice. Now the potential difference current through B and F. What is the current through this? Our next challenge. Now you see, 1 ampere current flowing this way, 1 ampere current flowing this way, both are meeting together and getting a new current 2 ampere. Okay, it means 2 ampere current is emerging from this loop, so 2 ampere current must be entering also. 2 ampere current must be entering also. Are you getting my point? 2 ampere current is entering and bifurcating into 2 equal parts. 1 ampere upward, 1 ampere downward. 2 ampere current entering, 1 ampere upward, 1 ampere downward, and again they are combining to form again 2 ampere. Are you getting my point? Okay, it means I have understood the current through this resistor also. So as this is 2 ampere, so this also must be 2 ampere because this is the same branch only. Are you getting? So what will be the voltage drop here? Here voltage drop will be between C and D. Voltage drop will be 2 into 2 equal to 4 volt. It is not asked, but you can calculate. What is the potential difference between B and C? B and C. What is the current here? 2 ampere. What is the resistance here? 2 ohm. Again 2 into 2 equal to 4 volt. Remember, that is also not asked, but it can be. Okay. Now I need to find out the potential difference between B and F. B and F. Okay. What do you need to do? Potential difference between, you can go that way also from plus, okay, plus VB like that, or you can directly club all these things. See, if I club it all these things, what I get? The potential difference here is 4. What is 4? Good. Here again 4. Here the between D and E, what is the potential difference? That is also 4. Current is 1 ampere, resistance is 4, so 4 volt. 4 volt. And what is the potential difference here? 4. 2 into 2, 2 ohm, 2 ampere, 4. So I got the F point. So what is the potential difference between B and F? I get 4 plus 4 plus 4 plus 4, 16 volt. Are you getting? So this is just directly just I have added it algebraically. Okay. If I want to go that way according to this technique, what I need to do between B and F, I have to go through any path. I can go through this path, or I can go through this path. I can go through this path also, but in this path I don't know value of I, that is why I cannot. So I have to choose any one of the path, either this way or this way. Okay, so I am choosing the path which is going upward. Okay, or this is or plus VB. I have already told you the starting point should be written as plus VB, minus current into resistance 4, minus, I think you have understood now why they are minus, because current is going this way, so this point will be high, this point will be low. So as you are going this way, you will be seeing the change negative, finally is low. So that is minus 4 here, that is minus 4 here. Now I am going this way. Here I will see minus 2, here I will see minus 2, then again here I will see minus 4, equal to VF. Okay, according to the Kirchhoff's law, if I go Now you see what I find from this expression. I have to wrap this question also, and though it is not attempted. Remember, that is find power through 4 ohm. Okay, remember, huh? Power through 4 ohm. Okay. And now I get VB minus VF equal to all these things to be added and shifted to the right. It is 16 volt. Okay, same answer. VBF equal to 16 volt. See, repeatedly I am getting this answer same, both ways. But I suggest which technique for you? Is it this technique is suggestible or this technique is suggestible? I repeat, this is suggestible, because using this technique you can do very large number of problems, or large but very complicated figure also you can solve it. Are you getting my point? In this technique you may do some mistakes. So that is why you should better try this technique. Now I was asked what is the current through 8 ohm. Okay, what is the current through 8 ohm? I think I should rub all those parts which I have already done. Okay, I have to rub all these things so that I can manage some space. Okay, very good. You see, I need what is the current through this. I know potential difference between B and F. B and F is 16 volt. It means potential difference this point and this point is 16 volt. It means potential difference this 2 point is 16 volt. Same point, na? B and F. No resistance is there in between, na? So what is the current through 8 ohm? It means current through B and F directly. Here through 8 ohm. Okay, is equal, potential difference is 16 volt divided by resistance, so it is 2 ampere. So another question is answered. You can give tick there. I have already rubbed it, na? So I can't, so you give. Okay, now you see 2 ampere current is flowing this way. Remember, 2 ampere flowing this way, 2 ampere flowing that way, and both are meeting at this point. It means the current flowing through is 4 ampere. Though it is not asked, but you can calculate current through F to Z. F to Z is 2 plus 2 equal to 4 ampere. Are you getting it? Okay. In the second question I have asked what is the power through 4 ohm. Okay. Therefore, power through 4 ohm equal to, I know the formula is I square R. So what is the current here? 4 square. What is the resistance here? 4. Are you getting? So 64 watt you will get, na? 64 watt. SI unit of power is watt. I square R. Okay. It is very easy. You can do. Good. That way you have to keep going. Nothing else. Now you see, as the 4 ampere current is flowing here. So what is the potential difference here? 4 into 4. Potential difference between F and Z. F and Z. 4 4 is 16. 16 volt. Are you getting my point? 4 4 is 16 volt. Okay. Now I can find, I have to rub all these things. I have to rub all these things. Okay. Let me rub. I can find the potential difference between B and Z also, though it is not asked. Potential difference between B and Z. Okay. How can I do? Say I am going this way only, Plus VB minus 8 into 2 means 16. Minus 8 into 2, 16. Then minus 4 into 4, 16 equal to VZ. So V minus VZ equals 32 volt. It means VBZ equal to 32 volt. Though it is not asked the potential difference between this and this, but I have easily calculated. Okay, that may be asked in the second part. Then you can calculate that what is the current through this 8 ohm. What is the current through 8 ohm also you can calculate. Okay, you have to go very slowly. No problem. What is the current through 8 ohm? Means current through B to Z, BZ, direct BZ. So what is the voltage between these 2 points? As you have calculated, the potential difference between these 2 points is 32 volt. That 32 volt will be experienced by 8 ohm also, because this branch and this branch will be parallel. So 32 upon 8 equal 4 ampere. It means 4 ampere will be flowing that way. Okay. Now you see, at this junction point, 4 ampere is coming this way, 4 ampere is going this way. It means total 8 ampere current will be going out of the circuit. So what is the current through ZH 4 ampere plus 4 ampere equal to 8 ampere. Okay, you have to, if once you that will break the chain, it will be very difficult for you. So you have to rewind the video once more. Okay, that way you can understand all these things. Now I am going to do this last problem. Find the heat dissipated through the resistor R equal to 2 ohm. What is the heat dissipated here? You see, now you see, in whole circuit, in this branch I have seen the current flowing is 4 ampere. In this branch I have seen the current flowing is 2 ampere. In this branch I have seen the current flowing is 2 ampere. Okay, this is the junction point. From this junction point, here 2 ampere, here 2 ampere, and here 4 ampere. 4, 2, 2. The current entering must be equal to 4 to 2, 8 ampere. It means 8 ampere current must enter. And as you have seen, 8 ampere is going out also, from the whole circuit network. So 8 ampere current flowing through this. So what is the heat dissipated? Heat dissipated formula in 2 ohm is I square RT. What is I here? 8. What is R here? 2. What is the time given? I think it was 2 seconds. Okay, so like that you can do 64 into 4, 250 joule. Okay, check the numerical part. Get the conceptual part from me and verify the numerical part, whether my answer is correct or wrong while multiplying all these things. Okay, you have to check all these things. You see, I have solved all the problems. Here Wheatstone bridge also there, Kirchhoff's law also there, Ohm's law also there. Are you getting your point? You can be asked what is the equivalent resistance between B and Z also. That may be another question. What is the equivalent resistance between B and Z? Though it is not asked initially, but you can frame a new question. Say you try, give a pause and try to do what is the equivalent resistance between B and Z. Let me wrap this part. Equivalent resistance between B and Z. Okay, let me do it. See, that is 2 series, because this is of no use. 2 to 4, 2 to 4, 4 4 2, because 4 parallel. 2 to 4, 2 to 4, 4 4 2 means this part has resistance 2. Now this series 2 2 2 2 8 ohm. This line has resistance all along from here to here. What is the resistance? 8 ohm. Okay, and 8 ohm and 8 ohm parallel. So 8 8 4. 8 8 4, because two resistors, equal resistance, when they are parallel, their result become half. 8 8 4. Then again this 4 is in series with this 4. 4 4 8 again, means the resistance between along this part, from this to this, it is 8. This is 4, this is 4 plus 4 8. Now this line and this line parallel. That is 8, that is 8, but 8 8 again 4 ohm. The resistance between B and Z is 4 ohm. Okay, see, without using pen and page you can solve these things. If there is any problem, you just rewind the video, and if possible I am going to again explain you one thing. 2 series, so 4, 2 series, 4, 4, 4, 4, 4, parallel, so this is 2. Now you see 2, 2, 2, 2, 1, 2, 3, 4, total 8 ohm. This 8 ohm and this 8 ohm parallel, it means 4. This 4 and this 4 in series, 4 plus 4, 8. This 8 and this 8 parallel, 8, 8, 4. So final answer is 4 ohm. Are you getting my point? And you can be asked what is the potential difference between A and F also. Okay, you can just let me calculate the potential difference between AF. VAF equal what? So that is also a question. What I need to do, you see, from A to F I need to have the journey through any route. From A to F we have lot of ways. I can go that way, I can go that way, I can go that way, a lot of branches, but I will choose the path this way. Okay, you can go that way and you will get the same answer, and confirm whether you will get the same answer or not. See, plus VA, okay, plus VA, current is going this way, so minus 8 into 2, 16. I am going this way, 8 into 4, minus 32. I have reached Z, then I have to go F. Now this will become plus, because I am going this way, current is flowing this way. So this point is high potential, this point is low potential, because current always flows from high to low. But for me, the final potential is high. That is why plus 4 into 4, 16 equal to VF. So I get VA minus VF equal 16 got cancelled, 32 volt. If you go this way also, you get same answer from A to F. If you go this way also, you get the same answer. Check it. And here you see, here one different term, it is plus. Why it is plus? You check it. While going this way, I get in this resistor final is high, initial is low, because current is flowing down. Okay. In other cases, I am going this way, means I am going from high to low, so change will be negative. This way I am going from high to low, it change is negative. But in this, it is reverse. Okay. So that is the final answer also. That may be also asked. So that way, guys, a lot of questions can be asked from this single question. A single figure I have made lot of questions, and you can also design from this questions only. Again, I think you can design any more than 10 questions. Okay, you just keep practicing, and I am sure you'll keep rocking also. Thank you guys. Bye.